carboxylic acids. Carboxylic acids. Okay, so a carboxylic acid is where you've got a C double bond O, OH. The name of carboxylic acids comes from this part of the molecule is what you find in a carbonyl compound, and that part of the molecule is what you find in a hydroxyl part of the molecule. And if you take the carb part and the oxyl part, then that's your carboxyl. Okay, carboxyl functional group, it's called. Carboxyl functional group. Carboxyl functional group. Okay, though it is not carboxylic acids are not carbonyl compounds. They do not react in the same way as aldehydes and ketones. Just because they've got the C double bond O does not mean that they react in the same way. The OH, by having the OH there, that changes the chemistry of these compounds, these functional groups, considerably. How do you name carboxylic acids? Okay, so if we have, for example, 4 carbons in a chain with all the hydrogens as well. Okay, so 4 carbons, that will be called butane. Butane is 4 carbons, and all you do is take off the E and put oic acid on the end. So it's butanoic acid. Here's another example. If you have, let's say, for 5 carboxylic acid, let's put a methyl group there, for example. And that would be 1, 2, 3, 4, 5. That will be pentan, oic acid, carboxylic acid. But you've got your number from the carboxylic acid from the functional group, 1, 2, 3. So it would be 3 methyl, just put it at the front, 3 methyl pentanoic acid. Okay, right, so next, carboxylic acid. Are they soluble in water? Okay, so soluble in water. What do you think? Soluble in water? If you take a small carboxylic acid, like this one, for example, this one is called ethanoic acid because there are 2 carbon atoms, ethanoic acid. Okay, and you take some water. Okay, and this can happen in various places. It is a polar bond because the oxygen is electronegative. You've also got a polar bond here as well on the OH. You've got dipoles on the water too. And you can form a hydrogen bond. Can be formed. A hydrogen bond can be formed between the water and the carboxylic acid. Remember, the hydrogen bond has to start at a lone pair. It can also happen, the hydrogen bond can happen off the OH as well. So yes, they are soluble in water because of the polar carboxylic acid. But as the chain length increases, so yes, soluble in water up to approximately 4 carbon atoms, they're soluble. But as the number of carbon atoms increases, as the chain length increases, the solubility decreases. I think I need to get a new pen. Solubility decreases. Okay, the solubility decreases. And this is because the carbon chain is non-polar. Yeah, and this is because the non-polar, the longer the chain, remember a carbon chain is non-polar, the non-polar carbon chain has a greater effect. So small carboxylic acids are soluble, greater effect, but larger ones are not. Okay. So are carboxylic acids acidic? Are carboxylic acids acidic? Are they soluble in water? Are they acidic? Yes they are. They're organic acids. They're organic acids. They're weak acids. Organic acids tend to be weak acids. Do you know the definition of a weak acid? A weak acid partially in water, partially dissociates into ions. Partially dissociates into ions. Okay, so for example, if we take the simplest carboxylic acid with just one carbon atom, what's that called? Methanoic acid. And aqueous. Okay, so in water it partially dissociates. We put an equilibrium arrow, and then it releases the H plus, which is the acid part, and then you're left with the salt part. Okay, so this part here, what you're left with, if we were to draw it out, okay, that's called the carboxylate ion. Okay, so that's carboxylic acid. This here is called the carboxylate ion. Carboxylate ion. Okay. Using paper. Carboxylate ion, right? So if they're acidic, then they'll do lots of reactions. Okay, so let's do first the reaction with metals. Okay, carboxylic acids and metals. Okay, with metals. So if you take, for example, you take sodium, for example, metal, and let's just keep it simple. Let's just put ethanoic acid. An ethanoic acid. Okay, what's going to happen? An acid and a metal makes a salt. So the H plus comes off, and then the Na plus. You don't have to show the minus and the plus. Metal and an acid gives a salt plus hydrogen gas. So we're going to need to times by 2, times by 2, times by 2. Okay. This salt here would be, it's named a bit like an ester. It's called sodium ethanoate. Sodium ethanoate. That's how you name the carboxylate salt. It's a carboxylate salt. Okay, what type of reaction is this? Well, the sodium is becoming sodium ion. So what's happening to the sodium? The sodium is becoming sodium ion, so it is losing an electron. Losing an electron is called oxidation. The H plus, there's two H pluses. The H plus is becoming hydrogen gas. So that therefore it's gaining 2 electrons. So that is reduction. So what type of reaction is this? It's a redox reaction. Okay, so this is carboxylic acid with metals. Also, carboxylic acids react with metal oxides, with bases. A metal oxide is a base. Okay, so for example, let's just which example? Let's take MgO, magnesium oxide. I'm just going to keep ethanoic acid, keep it simple. Okay, you've got to bear in mind that the salt is 1 minus, that part of the carboxylate is 1 minus, whereas Mg is 2 plus. So therefore you're going to need 2 of those in order to make it neutral. So we're going to have to put 2 in front of there, and we're going to put water. A base and an acid makes salt and water. And this reaction is called, this is neutralization, isn't it? This is neutralization. Sorry, the pen's not very good. Neutralization. What about with metals, with metal oxide? What about with alkalis? What's the reaction with alkalis? Okay, so if you take like sodium hydroxide and methanoic acid, so again, an acid and an alkali makes a salt. Life is easier because Na is 1 plus, and we need plus water. So there's no balancing to be done there. An acid and an alkali makes salt plus water. Okay, last reaction is carbonates. So this is carboxylic acids with carbonates. Carboxylic acid with carbonates. So this is where you take, let's take for example magnesium carbonate, for example, magnesium carbonate and ethanoic acid. Okay, and again you get the ethanoate because the H plus has come off, and acid is a proton donor, but Mg is 2 plus, so you're going to need 2 of them. So you need to put 2 at the front there because you need 2 of them. And you also, when you react with the carbonate, you get carbon dioxide plus water as well. Okay, so this is actually the test for a carboxyl group. Okay, this reaction here is the test. If you're asked how do you test for a carboxyl group, that's the name, that's the functional group, carboxyl group, you add carbonate, and if it bubbles, add carbonate, and then it bubbles, then you know it is carboxylic acid. Okay. Okay, test for a carboxyl group. Add magnesium carbonate or a carbonate. Okay, finally, the last little bit. It's carboxylic acids, but what about derivatives? Okay, derivatives of carboxylic acids. Okay, derivatives. Derivatives. So this is compounds. Derivatives of Derivatives of carboxylic acids are not compounds, these are functional groups that have been derived, that have come from carboxylic acids. So the classic one is that one, which is the ester. So can you see you've got that part there, and then this part here, and that's called an ester. When I'm putting R just means carbon. Either 1 carbon, 2 carbon, 3 carbons, that's what R means. Okay. Another one is ester, and another one is, you have the same part like that, and this time you have like that, and that is called an acyl chloride. Acyl chloride, okay? Acyl chloride. Now an acyl chloride, you need to know how to make an acyl chloride. Okay, should we do this first? Yeah, let's do this first. Okay, what we're going to do, I'm going to go through them. I should have gone through them in order. An ester. Okay, let's have a go at naming an ester. So if we have this ester, for example, okay, so 3 carbons there and 1 carbon there. Okay, when you're naming this ester, then you name this part first. So that's methyl, 1 carbon, methyl, and then you name this part here. So there are 3 carbons, so it's propan. Well, it should be propane, but you take the E off. Propan O8. the ester part is OH like that. Okay, when you're naming acyl chlorides, if we go, for example, like that, then it's 2 carbons, yeah, so it's called ethane, but take the E off, ethan, and we put the end OYl, like that, OYl chloride, and that's how you name the ethanol chloride. The other derivatives, so that's ester, acyl chloride, they've all come from carboxylic acids. The other common one is an acid anhydride. So again, if you have that same bit like that, and this time you have another, and R is just a carbon chain, so you've got this extra part here, and this is called an acid anhydride. Okay, acid anhydride. Okay, so if, for example, if the R was a CH3, for example, okay, so what if it was like, if it was CH3, O, C, double bond O, CH3, okay, that is called ethanoic anhydride, because it's like an ethanoic acid has been added on. Ethanoic anhydride. Ethanoic anhydride. Okay, and then the last one is amide. So if you have the RC double bond O, NH2, like that, then that is called an amide. Okay, do you see what they've all got in common? They've all derived from the carboxylic acid. That part, RCO, RCO, is something else added. The 2 final things is you need to know how to make an acid chloride. Okay, so how do you make that? How do you make it? Synthesize it. So you synthesize it by taking, you need to take the ethanoic acid and the chemical SOCl2. That's S for sulfur, OCl2. This compound is called thionyl chloride. Be careful with your spelling. Thionyl chloride. So you react those 2 together and it makes an acid chloride. Okay, so it makes the ethanoyl chloride. You need to know this reaction. And also gaseous sulfur dioxide, and also gaseous hydrogen chloride. So you've got to do this in a fume cupboard. You're making some poisonous gases there. That's how you make an acid chloride. Finally, how do you make an anhydride? An anhydride is simply made, so sorry, let's just box all this off. Whoop. An anhydride is made from 2 carboxylic acids. So if you take 1 carboxylic acid, with enough room, and you take another carboxylic acid and you remove water. You remove water, and that's how you make an anhydride. And if you think about it, anhydride, anhydrous means without water. Now I'm going to do another video giving more detail about esters, giving more detail about how to make an ester and how to make an amide. Okay, so that's another video. Thank you.